Rules on exponents. Let's talk about an exponent. An exponent is also called a power. It's also called a degree. It's also called raised to. So if I have a base and I raise it to a power, we have this written in exponential form. So, product rule. If you multiply same bases, example, have a to the m times a to the n, then add the powers, or add the exponential, the degree, the raised to, whichever you want to call it. So I have a raised to m plus n. My powers is m and n. My base is a. Base here is a. My powers here is m and n. So let's use an example that you can see the outcome. Say I have x cubed times x squared. My base here is x. My powers here is 3 and 2. So what are we going to do? We're going to take that base and write it once, and we're going to take the power of 3 plus 2 because we multiplied the bases. That gives me x to the 5th. That is my end answer. Okay, so now we have a quotient rule. Means that if I divide by like, or you can say same bases, then you subtract the powers, and it is always top minus bottom, meaning the power on the numerator minus the power on the denominator. Okay, so I can write this as an example of a to the m over a to the n, where a is my base and m and n is my power. So let's rewrite a, because it's my base, and it's raised to m, because that's my top power, minus n, my bottom power. So let's use an example. Let's use x cubed divided by x squared. Rewrite it because my base is x, so I rewrite it where it's just x, and I raise it to the power of the numerator, which is 3, minus the power of the denominator. 3 minus 2 is 1, but we don't write it x raised to 1. We write it as just x. My next rule is the power of product rule. And whenever I have a power of product rule, I can have a lot going on. I can have a as a base raised to m times b as a base raised to m. And on the outside of this parentheses, it's all raised to the power of n. So I can rewrite it where a to the m raised to n times b to the m raised to n. Whenever we have a base raised to a power, then raised to another power, we multiply the bases. Or, excuse me, we multiply the powers. So, I'm going to have m, or a raised to m times n, times b raised to m times n. And you know, and I'm using a and x's for my bases here, if you notice this. I don't know the value of a and x because it wasn't given to us, or the m and the n. These were making easier examples. So my base here is a raised to mn times b raised to mn. Since I don't know what the value of a and b is, that is my final answer. I don't know the value of m and n. That's my final answer. So let's just use an example. So let's say that I have x squared times y to the first, which we don't write the 1, but I'm going to in this case, and it's all cubed. Then that means I'm going to take everything in that parentheses and I'm going to cube it. And since it's a base raised to a power raised to another power, we multiply these powers. So I have 2 times 3 is 6. And then I have 1 times 3, and it just leaves me with 3. I don't know the value of x and y, so I'm done. So now let's look at the power versus the power rule, power of quotient rule. So, sorry, it's a little blurry. So the power versus quotient rule says that we have a fraction going on. So say I have a to the m over b to the m, and I'm going to raise it to some power. I'm still going to distribute everything inside this parentheses to this power on the outside. And we're still going to follow the rule of power raised to power rule. They multiply. So I have a raised to m times n over b raised to m times n. And I don't know the value of a and b, m and n here, so we are done. So let's use an example. I have x raised to the third power over y raised to the second, and it's all being squared. So I need to distribute this power on the outside to everything in the parentheses. Whenever we look at a power, we always look at what's in front of it, and what's in front of this 2 is actually the parentheses. So everything's getting raised to that power. And since it's raised to a power and raised to another power, we multiply powers. So I have 3 times 2 is 6, and I have 2 times 2 is 4. I don't know the value of x and y, so I'm done. If we know the values, we can finish this out. My next rule that we are going to work on is my 0 rule. This clearly states anything, and then I'm going to put in parentheses right here, other than 0. Okay, so this is anything but 0, okay? Raised to the 0 power is equal to 1. Well, let's talk about that. If I have a raised to 0, it's 1. If I have 1,000 raised to the 0 power, that's just 1. If I have negative 1 times 1,000 raised to that power of 0, then I have negative 1 times 1, which is just negative 1. So anything raised to 0 is 1 except for 0. I cannot raise 0 to the 0 power and come out with 1 because 0 will not ever equal 1. So in this case, everything raised to 0 power is equal to 1, except for the case of when 0 is equal to 1. It will not, equal to 0 power. Will not ever equal 1. Okay, so here's our last rule. We have the negative rule. We cannot have a negative exponent as our final answer. I mean, it can happen, but it's not going to be your simplified form. You still have to go another step. So this rule says that you're going to have to do the reciprocal or flip in order to make the power positive. So if I have a raised to negative m, I'm going to do the reciprocal or flip it to where my power becomes positive. If it's already in the fraction form, I'm just like, again, reflipping it or writing the reciprocal. If I have that's an x, zx over y raised to negative 2, I have to flip everything inside that parentheses. I'm not changing nothing inside the parentheses other than flipping it to make the power outside positive. And then, of course, we would distribute the power.